stellar evolution is mainly how the cycles of the star, how stars are formed, and what are the sequence these stars follows when they move from main sequence to different types of stars. So first, we can categorize the star in terms of temperature. If the surface temperature of star can be used to determine the color of the light which it is emitting out. Like if it's a very hot star, the hottest star, so it tend to emit out light in blue region. When it is a cold star, then it emit out light in a red region. We have violet, indigo, blue, green, yellow, orange, and red. That is actually in terms of energy as well. As we move from violet to red, the energy is decreasing. So as the temperature decreases, the energy which is emitted out from the star is also decreasing. These are the spectral types which we call, like we say, spectral type O star, B, A, F, G, K, and M. Then Hertzsprung and Russell diagram shows the variation of the luminosity or flux with reference to the temperature. So in this one, the axis, x-axis, it is decreasing 4,000, 2,000, half every time it's half, and this is representing a scale of or a magnitude basically, and this is magnitude compared to sun. We are comparing with reference to sun. That's why 0 or 1 will be there. It's like same like sun. So in this region, we'll have a cold bright star on the top right, and bottom right we'll have a cold and dim star. On the bottom left we'll have hot and dim star, and bottom and the top left we'll have hot and bright stars. This is also representing the positions of different stars. So you will find, like here, this is our sun region, that even the star temperature is low but their luminosity is high. Why luminosity is high? Because of their large size. Then we have blue stars or blue giant supergiants are there in this region. White dwarfs, they have high temperature but because of small size they are having a lower luminosity. And dim stars are there, and stars which are having a low mass, they are likely to remain in a main sequence for a longer period of a time. So life of star we divide into protostar, main sequence, and post main sequence. So protostar, basically what happened, all the like hydrogen, helium, they collide, they join together, and starting off the collision causing the gravity is causing the particles to come closer to each other. Then it become a pre-main, the gravitational collapse, the protostar continue to become opaque, and it will absorb infrared radiation. It will not allow infrared radiation to escape. So it create two things. One is radiation pressure, another one is gravitational pressure. Then it turned into a main sequence star. Then star continue to increase in temperature. Eventually, sufficient amount of heat is released, and that cause a hydrogen fuse. Like continuously, what is happening? Increase in temperature, it will become sufficiently hot, so it undergo a nuclear fusion of hydrogen. And when hydrogen nuclear fusion started, it releases energy, and the energy radiated by the star is balances with a so radiation pressure balances with the gravitational pressure. That is why the size of the star is not changing. But the radiation pressure outward from the core of a star balances with, so the pressure tend to collapse the star, so increase, so the size is constant here. But what happened in a post main sequence, once the hydrogen is used up in the core, so now there is no equilibrium or balance. So as the core contract, the gravitational potential energy causes an increase in temperature, potential energy change to kinetic. So temperature increases, and that increase in temperature cause helium fusion. And when it start to cause a helium fusion, it release energy and it turned into red giant. Then the death of the star, it depends on, like eventually a helium is exhaust in core of red giant and it collapse again. What happened next is depending on the size of the star. You may have a mass of a core. This is the mass of core less than 1.5 the solar mass, or mass, total mass of a main sequence mass below the 5 solar masses, like compared to 5 times the mass of the sun, that is less than that. So what happened, that type of stars, as they emitting out or turning into red giant, when the hydrogen fusion, helium fusion started, so it again releases the energy and very small and hot dense star is produced, that is the white dwarf, which cools gradually and become dimmer. And if we have a mass of a core between 1.5 to 3 solar masses, or 5 to 15 times the solar mass, then what happened, further thermonuclear reaction take place, and first the carbon burned and then the other element. So we will reach a red giant, turn into blue giant, and then there is a supernova which result in a formation of neutron star or a black hole. Likely the black holes are formed when the mass is about 15 times, and here it is forming a neutron star, but you're not dividing these two into like three parts. You're just learning two parts. One is a low mass star. Low mass star produce white dwarfs, and high mass or massive star produce basically black holes and neutron star. And the lifespan of the star on the main sequence determined by the mass. More mass is there, short lifetime on a main sequence, because the rate at which they undergo a fusion, that is at a faster rate, so they consume all of their fuel from the fusion. So our sun is at this position, likely it will be a red giant and it will be turned into white dwarf. So this was about the part which was related to the evolution, stellar evolution, or changes the sequence of the star. So low mass star, they will turn into white dwarfs, and high mass or massive star, black hole and neutron stars.